Hello and welcome to Bay College's Intermediate Algebra online lectures. Today we're going to be discussing absolute values and solving absolute value equations. The first thing we have to understand is what is an absolute value. An absolute value of a number is simply asking us what is the distance from this number and 0. And what we have to realize is the thing about distances is they're always positive values. Now, we can be to the left of 0, we could be to the right of 0, but we're not really concerned too much about what direction, but how far. And the reason why I stress this as a distance is because if you were asking directions and someone said, well, you have to drive -5 miles, you'd be looking elsewhere to get those directions because a negative distance doesn't really make sense. So we're just saying how far. So if we look at this example, if we have the absolute value of a equals some distance between a and 0, well, we have two possibilities, a to the right and a to the left. Well, the absolute value, their distance, is a unit. So we have the absolute value of a negative a, assuming a is positive, a units from 0. And here, on the right side of 0, the absolute value of a is a units from 0. Both are positive values. So if we look at an example here, we have the absolute value equals 16. This 16 represents our distance. Well, there are two possibilities that have a distance of 16 from 0. To the left of 0, we have -16, which lies 16 units to the left. And to the right of 0, we have 16, positive 16, which is 16 units away from 0 as well. So if we look at this, we're asking, what value of x would give me this? Well, that would be -16. What value of x would give me this distance? So these two possibilities are positive 16 to the right of 0 and -16 to the left of 0. So these are our two possibilities. Our distance is positive, but this indicates, well, this one's to the right and this one's to the left. So two possibilities. Now, if we look at the next example, it says the absolute value of x is equal to -16. Well, this is that statement, a negative distance. This does not make sense. There is no value that has a negative distance. Let's say you're working as a carpenter and your boss says, I need you to cut a board and it has to be -5 feet. Am I going to owe my boss some wood? Is that what he's asking me? That doesn't make sense. So when we see this, an absolute value equal to a negative quantity, we simply say it is a null set. It is no solution. So you can use this symbol, or you can write out no solution. All right. Now we're going to move on to an example where we have an absolute value equation. Now this is a simplified equation here. Our absolute value is isolated on one side of the equal sign, and that's the first thing we want to check, and we'll see that in following examples, that our first step is to isolate the absolute value to one side of the equal sign. And here we see that's already done. This absolute value, whatever this quantity might be, has to be equal to 1. Well, again, we recognize this is our distance. There is a distance of 1 to the right of 0, a distance of 1 to the left of 0. So negative and positive 1 are at the end of those distances. So what we have here is we can say, well, this quantity, whatever's in here, this distance, 5 minus x, could equal -1, because -1 does lie 1 unit from 0. This here, 5 minus x, could be +1, because 1 lies 5 minus x units from 0. So whenever we have an absolute value equation, we're essentially going to look for two equations, one being the negative and one being positive, to the left of 0, to the right of 0. And now we're going to go ahead and solve this. Well, we're simply going to use our rules of equality. What I do to one side of an equation, I do to the other. I'm going to undo my order of operations. So we want to undo this addition or subtraction using its reciprocal operation. 5 minus 5, we don't have to deal with that. It's 0. 0 and -x is just -x. -1 and -5 is -6. Now we want to still get x by itself. So we got to change some signs somehow. Well, I can multiply by a -1 to both sides, or I can divide by a -1 to both sides. It's going to result in the same thing. Essentially, it's just going to change the sign. So I get x equals 6. This is one of my solutions. I'm not going to wholeheartedly trust this. Eventually, I'm going to go back and check my work. In any math class, when you see an equal sign, check your work if possible. And here I'm going to do the exact same thing to solve this equation. I'm going to use the properties of equality, subtract 5 from both sides, and I'll skip that step because I already showed it here. And 1 minus 5 is negative 4. Again, we got to get x by itself. I have negative x, so we're going to change some signs. Whether I do that through multiplication or division, it's going to result in the same value. So now I have these two values, x equals 6 and x equals 4. So let's check our work. If I put 6 in for x, this would say 5 minus 6. Well, what is 5 minus 6? Negative 1. Does negative 1 lie 1 unit away from 0? The absolute value of negative 1 is 1. 1 equals 1. That's a true statement. It doesn't get any truer than that. So I've checked it. And when I check my work, I put a little check by there that says, yep, I checked it. It works. Now I'm going to try 4. 5 minus 4 is 1. The absolute value of 1 is 1. 1 does lie 1 unit from 0. So that's a true statement as well. So now we're going to move on to this next example. Now here it's a little bit different than this example here in the fact that the absolute value is not all by itself on one side of the equal sign. What we have to do is we have to isolate it. So let's use those properties of equality. Let's add 4 to both sides. And if I do that, I get the absolute value of 5t minus 4 equals 3 and 4 is 7. So now we've isolated this. Now we have to think. This is our distance. There are two possibilities from 0. And we're not going to go through illustrating the number line. Again, what we're going to do is we're just going to consider, I want two equations, one positive and one negative. This is my distance. So 5t minus 4, the number that lies to the left of 0, 7 units away, is negative 7. My other example, 5t minus 4 could be the positive 7. These are my two equations that I need to solve. To the left of 0, to the right of 0, two possibilities. So again, properties of equality, I'm going to add 4 to both sides. And I can do the same thing over here, add 4 to both sides. And we want to undo this multiplication because this says 5 times t. We use division to do so. So I divide this by 5, divide this by 5. And we're going to do the same thing over here. I'm solving two equations simultaneously. Any number divided by itself is 1. So that's how we undid that math. And over here we get negative 3/5. Over here we have the same thing. The 5's cancel. T equals 11/5. And now it's time to check our work. We found two solutions. Let's make sure they're true statements. Now, I'm actually going to work this one out in the original equation. We have the absolute value of 5 times t. Well, let's test this one. T is negative 3/5. Minus 4 more equals 3. Now, to simplify this, there's one of two ways. I could think of this as 5 over 1, and I could just multiply the top and multiply the bottom, our numerators and denominators, and I'd get negative 15/5. Well, negative 15 is evenly divisible by 5 to give me that negative 3. Well, the easiest way is using this property right here is to think any number divided by itself is 5. Well, if I'm multiplying by 5 and dividing by 5, we can simply simplify that, and I get negative 3. So let me just rewrite this portion here. Negative 3 minus 4, the absolute value of that. Well, negative 3 minus 4 is negative 7. And negative 7, the absolute value, that lies 7 units from 0. So it is 7. 7 minus 4 is 3. That is a true statement because 7 minus 4 is 3. Now to test this one, I'm not going to show this work because we've done it before. If I just plug it in, 5 times 11 over 5, the 5's would cancel. So we can just say that this is 11. 11 minus 4 is 7. 7 minus 4, did I say that right? 11 minus 4 is 7. The absolute value of 7 is 7 units from 0. So 7 minus 4 is in fact 3. So this does work, 11/5. So I'm going to check it. I checked both of them. They worked out. These are my two solutions. And I would answer any question accordingly. Maybe I'd write it in set notation t such that t equals negative 3/5 and 11/5. So that would be one way to illustrate the answer. For my students, we really don't need to use proper set notation, just t equals these two values. That would be fine. But other instructors might ask you to do it properly and use the notation there. I'm just going to erase some of this, because hopefully it's on video. If you need to see it again, you can always rewind, because I need a little bit of room to work through this problem here. Now, each problem that we're doing is going to progress a little bit different. They're going to be slightly different. We can see here, this is very similar in format to the previous question, but we're going to see it's actually a little bit different. My goal is to first isolate the absolute value, get this by itself, and I can do that by subtracting 4. Well, if I subtract 4 here, I also subtract 4 there. 2 minus 4 is negative 2. Now, here's an important concept. We defined absolute values to be a distance from 0. Can we have negative distances? Negative distances don't make sense. If I recognize that, I can stop right here and say the answer is no solution. And I'm just going to abbreviate there. So no solution or the null set, either one's appropriate. But what if we didn't recognize that? What if we weren't looking for that negative and we said, you know what, I know I need two equations, so I'm going to write them. A minus 2 could be that negative value, because this does lie 2 units from 0. And a minus 2 could be the positive value, because that also lies 2 units from 0. Now, if I go to solve this, I'm going to add 2 to both sides to get a by itself. Oh, and I'm going to get 0. Here, if I add 2 to both sides, I'm going to get 4. So you might be asking yourself, wait a second, if there's no solution, what am I doing finding solutions? Well, that's why it's so important whenever you have an equation, that equal sign, to go back and check your work. Make sure that these are valid. Let's put 0 in here. 0 minus 2 is negative 2. The absolute value of negative 2 lies 2 units from 0. So this is 2. 2 plus 4 is 6, equal to 2. Does 6 equal 2? Of course not. So this did not result in a true statement. It's not valid. This is not going to work and give us something true. And if we try 4, 4 minus 2 is 2. 2 lies 2 units from 0, so its absolute value is 2. 2 plus 4 is 6. 6 is still not equal to 2, no matter how we do it. So these did not result in any solution. So we can go back to this and say, oh, maybe I have to reconsider this. Yep, it's negative. We can't have negative distances. There is no solution. So even if you don't see that right away, if you're checking your work, you're going to return to that and realize, yes, that's what I have to do. All right, we're going to move over to this next example here. And we're going to see, again, it's the same format. We have to isolate this absolute value first. But this is going to be an interesting one, because if I add 4 to both sides, I'm going to get the absolute value of 2x plus 4 equals 0 when I isolate the absolute value. Now, what we have to ask ourselves is how far, because this is asking for a distance, how far is 0 from 0? Well, it's 0 units away. It's not any units to the right. It's not any units to the left. 0 is neither positive nor is it negative. 0 is neutral. It lies right in between. It's our transition between positives and negatives. So if I write two equations, 2x plus 4 equals the negative 0, and 2x plus 4 equals positive 0, I've actually written the same equation twice. This is the one time where we're not actually looking for two solutions. We're only looking for one, because 0 is neither positive or negative. It's actually the same value. It can be both if we want to think about it that way. So essentially, I only need to solve one equation, because if I subtract 0 or if I add 0, it results in the same thing. So 2x plus 4 equals 0. Here I can subtract 4, and I can divide by 2 to get x all by itself. Negative 4 divided by 2 is negative 2. Now, of course, we have to check our work. We're going to go back to the original equation. 2 times 2 is, or excuse me, 2 times negative 2, that's my x value, would give me negative 4. Negative 4 plus 4 is 0. The absolute value of 0 is 0. It is 0 units from itself. 0 minus 4 is negative 4. Negative 4 is negative 4. Well, it doesn't get any truer than that, right? It's what I like to call an is what it is statement. -4 is -4. So this made that statement true. All right, the last example we're going to do today in this lecture is what if we have more than one absolute value? Well, as long as we can isolate one of them, and in this case they're both isolated, here's where we just have to work through it. We might find two solutions. We might find one solution, as we did here, or we might find no solutions, because that's a possibility as well. There's also another one that we'll maybe see in next sections or future sections where we could have infinite solutions. Any number will work, and that can happen sometimes. So what we're going to do is we're going to treat this as if it was just one. Just pick one of these, and I'm going to choose this one. And I'm going to say, well, 8 minus y could equal the negative of this value. Let's pretend that this absolute value doesn't exist, because we're just going to look at all the possibilities. Well, if it's negative this value, I'm essentially having to multiply by -1. And because it has more than one term, we have to distribute the -1. So if I'm changing the signs, like I did in our first equations there, let's change the signs of all the terms. Notice how this y plus 2 is now -y and -2. And what if I say, OK, well, we also need the positive value. 8 minus y could equal y plus 2, where I don't change the sign of y and I don't change the sign of 2. Now we're going to go ahead and solve these. And we're going to see something real quick here, which is nice. If I want to isolate my variable, I've got to get it on one side of the equation. So I'm simply going to add y to both sides here. -y plus y, no more y's. I would have 0 y's. So I end up with just 8 on this side. Well, -y plus y, no more y's on this side either, and just that -2. Well, just from this statement alone, I can look at it and say 8 equals -2. I know that's not true. 8 is its own number. -2 is some other number. So this is not going to result in any value of y that's going to make this true statement. So I can move on to this one now. That one didn't give me any solution. Here, again, I want to get my y's on one side of the equation. So I'm going to add a y to both sides. Here, -y and positive y, no more y's. Y plus y, well, that would give me 2 y's, wouldn't it? Plus the 2. Now I can take this a little further. This is an equation I can solve. It has a variable. It's something worth going further. So I'm going to subtract 2 from both sides. And then I'm going to divide by 2. Now, by doing it this way with my y on the right side, a lot of students, they say 3 equals y. I like to see it the other way, y equals 3. Because generally, we like to read from left to right, so you can switch that. They mean the exact same thing, 3 equals y or y equals 3. But what do we have to do at this point? We have to check it. We have to make sure that this makes a true statement. So I'm going to put it in here. If y is 3, 8 minus 3 is 5. 5 lies 5 units from 0. The absolute value of 5 is 5. That's what we get there. And if I put 3 in here, 3 plus 2 is 5. The absolute value of 5 is 5. It is what it is. A true statement, 5 is 5. So we know that works. Here's my solution. And I am infallible because I know it works. I plugged it in. I checked my work. And that's what you should do all the time. This has been section 1.4 of Bay College's Intermediate Algebra Lecture Series. Thank you for watching.